In this video, we will be looking at factoring by GCF and grouping. By the end of this lesson, you should be able to factor polynomials using the greatest common factor and the grouping method. So if we recall multiplying polynomials, when we want to multiply these polynomials together, we distribute my 4x to both terms. I would get 12x. I added those together, 1 plus 1, x squared, plus 4x times 5, 20x. That is what I got when I multiplied those two together. That's what we've done in one of our previous lessons. So if we notice, these two terms, these two pieces are considered factors of our final answer. Factors are things that are multiplied to create a product. So in that example, 4x and 3x plus 5 were both factors of our 12x squared plus 20x. They were factors of that. If you also recall one of our earlier lessons, we had something like x plus 1. We multiplied that times x plus 2, and we would get x squared plus 3x plus 2. These two were my factors. So my factors would give me a product. When we look at the greatest common factor, or the GCF, we may shorten this and use GCF to talk about the greatest common factor. It's the largest monomial. Remember, that's one term. That can be divided out of each term in the polynomial. Remember, that is multiple terms. Okay, and a product can be prime when the only factors are 1 and itself. So if we can only divide something by 1 and itself, we consider it prime. So when we're going to factor using the GCF, we want to find the GCF of the polynomial. Then we are going to undistribute. So back in our first example, we did the distributive property. We distributed these two to get my solution. What we're going to do in this lesson is be given this and work our way backwards to those factors. So we want to undistribute, or go the other way and divide out the GCF from all the terms. So let's look at some examples. In these examples, we want to factor out each polynomial by finding the GCF, or the greatest common factor. I want to look at this and I want to find the GCF of these two terms. So I look at 5 and I look at 15 and I ask myself, what can I divide both 5 and 15 by? And my answer there is 5. I can divide 5 by 5 and I can divide 15 by 5. Then I want to look at my x's. I have x squared and I have x. And I ask myself, what can I divide both of those by? And I really want to look at what's the smallest power that I have. And this one has an x squared and that one has an x to the first. So I can divide them both by just an x to the first. So 5x to the first and 5x to the first. So when I do that, I think about my division that I did earlier in our lessons, having 5x squared divided by 5x plus 15x divided by 5x, dividing both of them by that. When I divide, 5 divided by 5 is 1. X squared, remember I subtract 2 minus 1, I have x to the first, plus 15 divided by 5 is 3, and my x's will actually cancel. I'm going to rewrite this and just say x plus 3. But this is one of my factors. The other factor is what I divided by to start with. So my factors are going to be 5x times x plus 3. These are my factors. If I wanted to check that, I could distribute, and I should get back to my original problem. These two expressions, when multiplied together, will give me 5x squared plus 15x. Let's look at another example. If we look at example 3, I have negative 2x to the third minus 6x squared plus 8x. So I want to go ahead and ask myself, what is my GCF? So I'm going to leave some space and go ahead and write down here my GCF. And I want to look what number can I divide all of these numbers by. And I see that number is negative 2. I can divide negative 2 by negative 2, negative 6 by negative 2, and 8 by negative 2. And then I look at my x's. I have x to the third, x squared, and an x. So they each at least have an x to the first. Okay, so I'm going to divide each of those into, I have negative 2x to the third divided by negative 2x, okay, minus 6x squared divided by minus 2x, and then plus 8x divided by negative 2x. So when I simplify that, I get negative 2 over negative 2 is 1, x squared. Negative over negative is plus 3x, and a positive over negative is a negative 4. My x's here will cancel. Okay, so I want that this is one of my factors, and I have my other factor here that I divided everything by. So negative 2x times x squared minus 3x minus 4 are my factors. If I were to multiply these, if I were to distribute this in here, I would go back to my original equation, my expression there. Okay, let's take a look at one more example like this together. We're going to look at number 5 on your paper. So in this case, this looks a little bit different in that I have some parentheses in my initial expression. So what I want to look at here is, again, I want to find my GCF. Okay, and here my GCF, I have a term right here, and I have another term right here. So if I look at both of those terms, I notice that I have an x minus 1 here and an x minus 1 here. Instead of it being a monomial, it's actually a binomial. So my GCF is going to be x minus 1. I'm going to divide this term by x minus 1, and I'm going to divide this term by x minus 1. So when I do that, when I divide them, just like in this example, how my x's canceled out over here when I canceled out my x's, in this example, the x minus 1's will cancel out. Okay, and I'm left with here, I'm left with a y and a minus 6. So I write them together, y minus 6. And then what I canceled was x minus 1. Those two together, when I multiply them, will give me this. So these two are my factors. Okay. If you go ahead and flip your page over, we're going to look at factoring by grouping or double factoring. So we're going to use the technique that we did in number 5 in this example. So if a polynomial contains 4 or more terms, so we're looking for 4 terms. You know, as in example 7, I have 1, 2, 3, 4 terms. It may be helpful to put the terms into groups of 2 and factor out a common factor from each of the groups. So again, we find that GCF. I have 1, 2, 3, 4 terms in example 7. So I'm going to group them into 2, just like that. So now I want to look at each of the groups and find the GCF. So I look here, I want to divide each of these, but if I notice here, my GCF for this one, I can't divide 2 and 3 by the same stuff, so there's nothing there. But this one has an x squared and this one has an x, so my GCF there is an x. And then I'm going to look at my other one over here, my GCF of my other parentheses. I can't divide by anything other than 1. This will actually turn out to be prime. The factors are 1 and itself. If we notice that this one has an x, but I don't have an x here, and again, I can't divide 2 and 3 by the same thing, so my GCF there is just 1. So I'm going to put plus 1 and a plus 1. It's a positive 1. So here, I'm going to factor out that x, so 2x squared divided by x. I'm going to write my x first. I'm going to write 2x plus, my x's will cancel here, I just have 3. And then I'm going to write my plus 1, and here 2x. 2x divided by 1 is 2x, and 3 divided by 3 is just 3. When we factor by grouping, if you notice, I have a 2x plus 3 here, and a 2x plus 3 here. Something should always match here. If you get something that doesn't match, you want to go back and look at your work. So here I have 2x plus 3 over 2x plus 3, they cancel. 2x plus 3 over 2x plus 3, they cancel. I'm left with x plus 1. And what I factored out was 2x plus 3. So these are my two factors. If I were to multiply them together like I did last unit, I would get back to my 4 terms that I started with in my original expression. Please make sure you bring these notes to class. This is our final example we're going to do in the video. We will continue to practice this, and we will work with factoring much more in the coming days of this unit.